Hello students, welcome to Learn Digital. In this video we'll talk about the fourth chapter from the book Object Oriented Programming with C++, and in this video I will talk about functions in C++. So let's start. What is function? So function is a collection of statements for a particular problem or for a particular task to be solved. So function always will have a name. Suppose we have a function called add. So the name says that we will have some instructions together to perform the addition. So addition of integer, addition of float. It is based on our intention, what we want to make. So suppose we want to add to integer. So in this case we have a function called add, and it will add integer x and integer y. So in this inside the function we will do this thing. Integer, suppose z, we have a local variable inside, and z is equal to x plus y, and we can return z. Why we are returning z? So from some of the other functions, suppose we have a function called main. So from main we will call add a function when we want to add two integers, suppose 2 and 3. So in this case addition will not be performed in main, rather it will be performed outside main, where we grouped the instructions which will perform this addition task. So this add will call actually this definition, and this instruction will be executed by the compiler, and z as a result of x plus y will be returned, because we just mentioned that this function will return integer, and this will be returned to this place. So our task is over. The result 5 is returned in this in place of add. So we can have any variable integer, suppose a. So a is equal to add 2 comma 3. So this way we can get the result of z in a. So this is the mechanism of creating a function and calling a function. So this is called user defined function, because add is not defined in compiler, add is not defined in the library. In this case we have created the function add. So this add function is like this. Int means it will deal with two parameter or two argument or two data values. So here the return type of the function is integer. See, the z is integer. So we want, so this statement you have to make before creating the function. This is called declaration of the function. So prototype declaration of the function. So it is very important to understand the design of function, how to design the prototype, how to create the function, and how to define the function, then how to call. So this is the general understanding of function. So I am just clearly writing the components of function, and this understanding is very much important for any programming language, because in any programming language you have the concept of function, because function is actually a block of statements, and this block of statements will perform some specific task, and this block will be named with a particular user defined name. Suppose in this case we have add, and in every program you have an execution point from where the execution starts, and that is always from main in case of C and C++. So in main the execution actually starts, and the first instruction will be the execution point. So if add is called here, so this the execution point will go from this point to this is called function call, and this is the definition. So it is your entire, this is the program, the whole program is this. Here you have main and you have add. Suppose you have another function called subtract, sub. So in this case the sub function will be called from main maybe. So we have another function called suppose display. So here we have another function called display. So display function to just print out the output, print the output. So from add you can call display, from subtract you can call display. So any function can call any function, and this is the actually a design of a function. So let us write the components of function here. And in C also we have the same architecture in C, and in C++ also this supports the function mechanism. And when we'll discuss object-oriented programming concept in C++, we'll again write functions while creating class and object. So here function has prototype. Prototype means the structure, the function actually, the architecture of the function what we are going to create. So that this will be the return type. Then first the return type, suppose integer is the return type, then the name of the function, suppose add is the name of the function, then the list of argument, suppose integer comma integer. So it is an example. So you can create any function, and you have to give a valid name, because giving a valid name is a good practice. If you are writing a add function and you are naming it subtract or multiplication, so it will not actually a good practice, it will not be a good practice. So here integer is the return type, and this is the name of the function, and integer and integer, two values will be dealt with. So this is the prototype. So number one is the prototype. So while creating a function you have to design the prototype. In the program you will mention this line, the beginning of the program, and then you will start defining the program. So the program will look like this. This is your prototype design. Integer add integer comma integer, this is the prototype. Here you have the main, so in this main you are calling the function add 2 comma 3, suppose. For the timing you just consider, I'm just showing the logical part. The code may include few other lines to just complete the program. So at this point I'm just showing the logical structure of creating a function and calling a function. So here this is the prototype. Then second one is the definition. Definition, and here we have the definition, the second part. It is like this: add integer x, integer y, and we have suppose z is integer, z is equal to x plus y, and return z. So here this is the definition of the function, how the function will work. Actually only by prototype declaration this will not work. So when you are calling you must have the total definition how the function will work. Otherwise what will be done when the function will be, we are having the definition here, and this is called function definition, and this part is called function call. So this is the third function call. So here see, when this is called calling function, this part when you are calling the function, we are writing this name. When you are calling the function, and this part is called called function, and this is called the prototype when you mention this. So this is a correct program, this from this point to this. So now based on so this point, based on the values you are sending 2 comma 3, so these are 2 comma 3. Sometime you can send like this, add a comma b. Here a and b are variables, so you must have defined a b as variable before you use those in your program. So here a and b. So in this case, what is actually happening, this type of call, you are calling the function with the name and first bracket and the closing first bracket and with semicolon, and inside the brackets you are just sending the arguments, because that a b will actually go to x and y. These are local variables. So it is this function chapter is already there in C. So you will if you have any other if you have query, if you have like if you want to know in a very detailed manner, you just go through the function video in C, which I have uploaded. So here a and b are the arguments. So this is called call by value method of calling the function, where we are sending the value of the arguments. Value means value, in this case value means a and b having 2 and 3. So we are actually sending 2 and 3. Here a and b actually representing the value, the copy of the value 2 and 3 will be sent to the called function, here a and b. So x will be having 2 and 3, y will be having 3, so z will be having 5, and 5 is returned, and 5 will come to this place when you are returning, where it is called this return will actually takes place at that point. So if you are having another variable called c, here c is equal to add, you can call like this. So and you can print the c also. So here this is called call by value. So in C it is there, in C++ also the call by value is there. So there are other type of calling calling type, which is a call by reference and call by address. So these two type of calling method is there. So we'll go to this section. Definitely we'll go to this section, and let us go through the book. So what I'm just discussing, it is already there in the book. So if you go through the book, it will be clear. So what is the purpose of keeping the book as a reference side by side? Because teachers should not be confused while while studying for the exam, while studying for keeping a book as a reference. So I'm just referring this book, which is like actually being used in many of the institutions as a reference book, so student will not be confused. So when you go through, so I would like to go this one. Every function is returning something. So when you write void in front of the in place of return type of any function, suppose add like this. So in this type, this void means no return. So if you are like writing like this, so no need to return anything, it will be like void in this case. And I'm just talking about the previous example. Here we wrote return z, so this line will not exist because we are not returning, because we just put void in place of return type. We don't want to return anything. The void means no return, void means null, void means nothing. So is a keyword void. So add will not return anything. This return statement will not work. So the main is a function which start this execution starts. So every function has a return type. So here in the main is actually the return type of main is actually int, because it returns implicitly returns integer value to operating system. So this part I will cover later. Just for the timing, you just keep this mind that main returns integer value to the operating system, because it is also a function. So function will return something, whether it will return or not, whether it will return or not, this will be actually set by the uh, user or programmer. But in case of main, it is already declared in the compiler. So we just define the function. In that case, this is the actually implicit return to the operating system, so that the operating system understands that the execution of the program is successfully completed. So here when we go further in the book, so you'll find function prototyping. That means the function name of type, return type, then function name and argument list, integer, float, integer, character, whatever the way you want, because your function is actually implementing or solving a task. So any task, it's based on the task. What will be the structure of your function? Name of the function, return type, name, then argument list. What will be the structure? It depends on your task, because we don't know what problem you are going to solve. And let us go further. Then call by value, then call by reference. So call by reference is actually see there is a concept. So let me explain this, like with the previous example, or with another example. We have a function called swap, function, and it returns suppose nothing, no problem, and it is having a value integer and integer. This is the structure of the function. Here we have a main, and which is actually calling swap function with a and b, and a is equal to 2, b is equal to 3. So we swap means we want to x a equal to 2, b equal to 3. So here the result of the program, or the effect of the program will be like that: a will be 3 and b will be 2, and this will, the value of b will be placed here and the value of a will be placed in b. The value will be interchanged actually. So the interchange of this function will do the interchange. So how to do that? Here we have a function called so after swapping, the program is not over. After swapping, you want to print, suppose cout a b. So when you are initializing a with 2 and b with 3, so the output will be like 3 and 2. So we already interchanged because you call the function. So how the function will work? swap swap void and integer x, integer suppose y. So here suppose z, temporary variable, integer t is a function just for swapping. The mechanism of swapping formula works like this. It's a simple algorithm. T is equal to x, and x is equal to y, and y is equal to t. So this actually doesn't replace the value of x, doesn't erase the value of x when you are like keeping the value of y in x. So this will be stored here 2 and 3 previously. So when you are keeping y in x, so this 2 will be replaced. So before replacing, or before like overwriting 2, you have to keep t 2 in t. So at that time you can do this. So this will be the first statement, this will be the second statement. The third statement, there is no problem. Once you kept the value of y in x, so in x in y x, so in y the value of t will be there. If you try to put the value of x in y, so see the value of y is x is already updated with 3, so y will again have 3. So if you want to put the value of x in y, you have to put the value of t, because we just kept the value of x in a temporary variable. So this is the mechanism of swapping. It is not related to like function calling by reference. So reference part will come now. So see, when you are doing that, so interchange is over, so you are getting the interchange value. But see, the if you print here, it will not be interchanged. You called the swap function, but this will not be interchanged. It will print 2 and 3. So A and B will not be interchanged because here the copy of A and B, the value of A and B is sent to X and Y, not the reference or not the whole the actual argument. We call actual argument, these are called a formal argument. In the formal argument, if you make changes in the actual argument, this will not problem with call by value method. So in call by value method, the one thing is very advantageous, that if you do any changes in the formal arguments, no changes will be reflected in actual arguments. This is for your the data protection or security. But sometime we need to do something when so that the function, external function, can change the the value of actual argument. So in that case we need to have reference. Reference means when you will make change in this formal argument, the changes will be reflected in actual argument. So how to do that? So with this example we'll do that. So we'll send the reference of the actual argument to the function. This will look like this. We will send A comma B similarly, but in swap, the swap will hold like this: integer ampersand of x comma ampersand of y, integer. So it will be integer. So integer. So here the A and B, when it will be sent, so the reference of A and B will be sent here, and this means the reference. So here now when you will work on this, that t is equal to x, x is equal to y, and y equal to t, then you will find the value is changed. It will be 3 and 2. So when you change in the formal argument, the actual argument, the value of actual argument will be changed. This is called reference. So another method is called call by address. So it is already there in C. So what is the mechanism? In call by address, the function structure looks like this. We have to use the pointer in that case because we are sending address. So to hold the address, we need to create the pointer variable so that it can hold the address. So in that case we have to send ampersand of A and ampersand of B. It is already there in C also. You can go through the function video which I uploaded in case of C programming. So in this case we are sending the address of A and B, and this pointer x and y, pointer x, pointer y, will hold the address of A and B. So when the and this will be again a strict t, it will be a pointer, so which can hold the value at address, the value at address x of x and the value at address. So everything will be in terms of like pointer. So now we are actually dealing with the value at address. So asterisk means value at address. So this is very important term. So see, value at address x, address of x means here it is here it is A, actually the value of A. Actually x is actually holding the address of x. X is again holding the address of A. So when you are sending the address of A, suppose the address of A is 100 address location and B is 200. So in this case we are talking about the value at address, the x holding, the address the x holding is the address of A is 100. So the value at 100 is 100 is 2, sorry, in this case it is 2, is the change value. value at 100 is 2 and value at 200 is 3. So we are just referring asterisk x means 2 and asterisk y means 3, and t is a temporary variable. So t no need to be a pointer. And here so the 2 will be so 2 will be stored here, and at 100 we are sending the value of value at the address y holding, that is b, that is 3, will be stored in x, and in x, so the value at address x holding will be replaced by 3, and value of t will be again stored at the address y holding t, which is holding the value of x, will be stored at the place where what the y is holding, that is 3, that is 200. So in location 100 3 will be stored, in location 200 2 will be stored. Means we are changing in the formal pointer variables, and pointer variables are holding the actual address of a and b. So it is obvious that changes will be reflected in at the of the value of a and b, because the variable is, these are the actual name, and actual thing is actually the location. So if we can deal with, if we can like access the location anywhere in our program, so their value can be modified. So this is the third mechanism, what we call the call by address mechanism. So in C we have another in C we have call by value, and we have call by address. In C++ we have call by reference, another mechanism which I already discussed. So another concept here is called inline function. So inline function is actually when you create a function with the name with the keyword, with the word inline. So inline any function. So here this actually this function, when you call, very simply I'm just discussing, add is the function which you made inline. So when you call add, suppose here are instruction cout, c plus b, suppose there are 3 instructions, this is the function. So when you call the function, actually you are copying the full entire definition of the function at the place of calling. So, and previously what we saw, that when we call a function, that compiler, the flow of the execution goes to the function, that is we are actually the flow we are sending to the function where it is defined. So in case of inline function, the flow is not going anywhere, the code is pasted here. See, the code is copied here. So in this case, what is the advantage? Advantage is that the overhead of calling a function and going to the definition is not there, so it will take less time. This time will be reduced, and the compiler will get the code at the place it is called. So but when the function definition is large, so copying will take large very much time. So in case of large definition, it is not practical, it is not advantageous. But in case of small definition, when the function has a definition, a small definition, 2-3 lines can be made inline. So this is the basic fundamental understanding of inline function. You go through the book, you will find very easy. So this way we cover function, and the function overloading part is there in this function chapter. So we'll discuss when we discuss object-oriented concept. We have a friend function, virtual function. These are the concepts already mentioned in function chapter, but not in a elaborate manner, just they mentioned. So we'll talk about this, we'll do programming on that function, friend function, in that one function overloading, and again inline function also will write programs. So we are closing function chapter here. Thank you.